then it'll be done. So this is what you get for asking me questions. I'm going to keep you forever. Okay, so this is number 20 on the review, the boot camp review. So it's the integral of x to the 8 over 5 minus x to the 9th squared dx.
Mm-hmm.
So the big thing that you learn in Cal 2 is how difficult it is to integrate. It's easy to differentiate. We have quotient rule, we have product rule, we have all of these rules, and we can integrate. We got a chain rule, we have all these rules. That's not true for integration. And basically right now, all you guys know is like add 1 to the exponent, put it over it. You know that one, and you know the integral of the sine is negative cosine, you know, e to the u, you know those basic ones that are on that sheet. And we're going to learn in unit 3 all kinds of other techniques. But since you don't have any other techniques, you know that you're going to have to do one of these basic ones. And in this case, you're going to want to recognize that this is going to be a u substitution. It's a pretty classic u substitution, because if you let u equal 5 minus x to the 9th, when you take du, which is part of the process when you're doing a u substitution, you take the derivative of u, you'll get negative 9x to the 8th, but you'll get an x to the 8th, which makes you happy because you have an x to the 8th in this original problem.
Okay.
So you realize that, and it is just from patterns and practice, you realize that 5 minus x to the 9th would be a good choice for your substitution. Then you take du dx, but you go ahead and like sort of multiply through by the dx. So I'm just going to say du, and then I'm going to put the dx on the other side, and you'll see why. So taking the derivative of this is the negative 9x to the 8th, and then we do put the dx here.
Mm-hmm.
Okay, so are you okay with that?
Yeah.
Yeah, okay, so now the idea is to rewrite this integrand in terms of only u's. So I need to get rid of anything that has an x. I need to get rid of the dx. So I've got x to the 8 dx right here, and I have x to the 8 dx right here. And on this side, this guy, it's only off by a constant. So I can, in essence, solve for x to the 8 dx by dividing both sides by the negative 9. Okay, so then I can think of, and then dividing by negative 9, same as multiplying by negative 1/9. So I have negative 1/9 du is equal to x to the 8 dx.
Mm-hmm.
Okay, so this allows me to replace x to the 8 dx with negative 1/9 du, and then I'm going to replace 5 minus x to the 9th with just u. Okay, so I'll do exactly that. So it's the x to the 8 dx, I'm going to write, I'll just kind of do it like this, just to negative 1/9 du, and then it's going to be divided by u squared. And I normally wouldn't do that. This is kind of like an intermediate step. What I would do is I would say I'm going to pull that negative 1/9 out in front, because that's just a constant. So it just tags along. And then a lot of times du over u squared might be prettier to write that as u to the negative 2 du.
Okay.
Because we like, and then now we get to use the only really formula that we have for integration, which is add 1 to the exponent and put it over that which you added 2. So this is negative 1/9, and then this will be u to the, and I'll show the steps, u to the negative 2 plus 1 divided by negative 2 plus 1. And then you always have a plus c when you have an indefinite integral. And then, so then finally this will be negative 1/9, and then u to the negative 2 plus 1 is just going to be u to the negative 1, right?
Mm-hmm.
Over negative 1 plus c, and so then this will be negative 1 over 9u plus c, right? Because positive. You want me to do positive? So I didn't look. Yeah. Are you okay?
Mm-hmm.
And then you would say, what was u though? U was this 5 minus x to the 9th. So we would rewrite it as 1 over 9, and then 5 minus x to the 9th plus c will
Okay.
be our answer.
Okay.
Yeah. And you can actually check every integral by differentiating it and seeing if you get back to the integrand.
Yeah.
So you check by differentiating. So you would want, if you were going to use, if your function is f of x equals 1 over 9 times 5 minus x to the 9th, the way you would want to differentiate that is to first think of it as f of x equals 1/9 times 5 minus x to the 9th to the negative 1 power. Just rewriting. I haven't done any differentiation yet.
Okay.
Now I'm going to use the chain rule, which means I'm going to think of that 5 minus x to the 9th. It's kind of like my u. You know, it's just a thing. And I'm going to do it. So the derivative is going to be 1/9 tags along. Then I have the negative 1. I rewrite the inside. So that's 5 minus x to the 9th to the negative 1 minus 1, because I'm differentiating, times the derivative of the inner function. So the derivative of 5 minus x to the 9th is the 9 comes in front, so this will be derivative of 5 is 0, and then you'll have the minus, so negative 9x to the 9 minus 1.
Okay.
Right? And so then this cleans up. Notice your 9s are going to cancel. Your negatives are going to cancel. You're going to have x to the 8. And then this is going to be negative 1 minus 1, which is negative 2. So I'm going to write that as 5 minus x to the 9th squared, right? Which that was my integrand. See?
Okay.
So I know that the
Okay.
antiderivative is correct. Okay. Because when I take the derivative, I get back to the integrand. Does that help a little bit?
Yeah.
So just kind of, I mean,